There's another force of nature. It holds atoms and molecules together, creating the shapes that surround us. It's called the electromagnetic force.
It's so mystical when you leave in the morning in the fog. You're just looking around, and then you see these shapes will come out of the fog.
They are big, heavy objects, far bigger than anything that we've created floating on the sea.
Doug Allen is an underwater photographer. And he wants to track down a dangerous and unpredictable shape. He's come to Newfoundland because this is iceberg season. And this place is called Iceberg Alley. Icebergs from the great glaciers of Greenland have drifted south to these shores. From here, ocean currents take them out into the Atlantic. And that's when icebergs can become lethal. Each summer, hundreds of icebergs drift into shipping lanes and oil fields off the coast here, threatening a multi-billion-dollar industry.
We've got to remember it was an iceberg that sailed past Newfoundland which ended up sinking the Titanic.
Icebergs are some of nature's most spectacular natural sculptures. And they can be massive, hundreds of thousands of tons of solid ice. But despite their weight, icebergs never sink to the bottom of the ocean. They float. This strange property is a direct result of the force of electromagnetism. The force of nature that binds countless billions of molecules of water together to create these bergs.
Water is a polar molecule. It has a positive end and a negative end. And at normal temperatures, the kinetic energy, the energy of the movement of the molecules, is way stronger than this polar forces. But as the water cools down and the molecules move more slowly, they begin to affect how the molecules line up.
Water molecules are electrically charged, and opposites attract. The positive hydrogen atoms of one water molecule bond with the negative oxygens of others. And as water freezes, the molecules arrange into a lattice of hexagons. And that makes them take up more space.
Ice is a really structured substance. It's almost hollow. It's a lattice structure. And as such, it's less dense than water. And the fact that it's less dense means that it floats.
Almost all other liquids become more dense when they freeze. But water expands. The innumerable hexagons in each iceberg mean a 100,000-ton block of ice can freely float in the sea.
Icebergs still pose a significant hazard to shipping, not just local shipping to St. John's, but also shipping coming across the Atlantic.
Ever since the tragic loss of life on the Titanic, icebergs have been intensely monitored. Today, Doug is joining a team of scientists who want to predict how icebergs behave. The team want to gather data on the shape of an iceberg, information that will help predict its trajectory out to sea. The scientists are using specially designed remote sensors to scan icebergs for from every direction.
It's a complicated jigsaw. It's a little bit, you could think of it as a crime scene where you have the forensic people go in and they pick up little bits of clues and together you make a bigger picture.
Aerial mapping and sonar robots are still in their test phase, so there's no substitute for first-hand observation. Particularly underwater, where the shape of the iceberg becomes just a shadow.
It's hard to piece together what we're seeing above water with underwater without your imagery, so that's what this is going to be really helpful for.
I'll actually get a picture of what the thing actually looks like, so they can hopefully tell more about how accurate their sonar picture is compared to the real thing. It's quite eerie going down the side of the iceberg. You're going down into the darkness, into the blue, into the green. And very occasionally there'll be this really loud thump, just like someone had hit you with the flat of their hand in the centre of your chest.
Being this close gives Doug an unrivaled view of the shape that's hidden beneath the waves. Thanks to the electromagnetic force that holds frozen water molecules together, ice floats, but only just. 7/8 of an iceberg is beneath the surface. The part underwater is called the keel. It catches the ocean's currents and affects the speed and direction the iceberg will travel. Up this close, Doug has discovered the keel of the berg is riddled with even more intricate shapes.
So while I'm swimming along the iceberg, I'm very aware of the dimpled shapes. It's like a giant golf ball on one side of me. And I'm just hoping that all these sort of observations from me myself and the fact that I'm putting them down on film, I'm hoping that that will be useful for the scientists.
How was that?
How was it? It was cold. It's a little bit murky. And I'll tell you all about it when I get on the boat.
The irregular and hidden shape of iceberg keels means predicting their trajectory is still an immense challenge.